For this question, given complex number 3 plus 3i and another complex number 3 plus 2i. First, write the first complex number conjugate of z1 in polar form. Then we have to express this operation in the form of a plus bi. So we have to simplify this operation into standard form. So for question A, the conjugate of z1 will be equals to 3 plus 3i. Change the imaginary part sign from negative to positive. Then, in order to obtain polar form, we need to find its modulus, where modulus is a squared plus b squared. It will give us 3 over 2. Then we find its argument. So in order to find its argument, we have to know where is the Argand diagram for positive 3 and imaginary part also positive 3, it will be at quadrant 1. So second step, we're going to find its basic angle. So shift tangent, B is 3, A is 3. So this will give us pi over 4. Therefore, the argument will be equals to alpha for first quadrant. So this will be equals to pi over 4. So finally, the polar form of this conjugate of z1, it will be equals to 3 sec 2 and then cos theta is pi over 4 plus I sine pi over 4. Then we proceed for question B. Substitute the conjugate of z1, so which is 3 plus 3i, times z2, which is 3 plus 2i, then divide for a number 13, plus the conjugate of I cube will give us negative I, divided by negative z2. So negative z2, it gives us negative 3, negative 2i. So we have to operate, simplify what is the complex number here, and then find out its conjugate. So for this part, we're going to expand one by one. 3 with 3, 9. Then 3 with 2, 6i. Then 3i with 3, 9i. And then 3 with 2, 6i squared. Divide by 13. So at the same time, we have to find the conjugate of this answer. So notice that here is a division for our complex number, negative 3 minus 2i. So what we need to do, we need to time with its conjugate, which is negative 3 plus 2i. So the conjugate of this answer. Simplify our expansion here, where we know that I squared is equal to negative 1. So 9 minus 6 will give us 3. Then 6i plus 9i will give you 15i over 13. So for this part, we are going to expand the numerator, negative I with negative 3, so it becomes 3i. Then negative I with 2i will become negative 2i squared. Divide by the complex number with its conjugate. So straight away we can do a squared plus b squared. So this we have to conjugate again. Then we simplify here. So real number divided by 13, imaginary number divided by 13. So finally, for this part, we simplify the I squared here, it will become negative 1. So negative 1 times with negative 2, it gives you positive 2 plus 3i over this negative 3 square is 9, negative 2 square is 4, so 9 plus 4 will become 13. Then we simplify here. This will be 2 over 13. So conjugate, you will change the positive side to negative 3 over 13i for imaginary part. So you will find out real part, operate with real part. Then imaginary part, operate with imaginary part here. This will give us 5 over 13. Then plus 12 over 13i as 15 minus 3 will get 12. So what is important here? So for the question A, state out the conjugate of Z1. This is your basic. And then we find the modulus, concept of finding modulus, and concept of finding. So these all together, concept of finding, argument. Lastly, express it in polar form. So for question B, so the first concept you will see how you're going to apply your multiplication, how you expand your complex number, and then the definition of I cube will be equals to negative I, so this is your basic. Then simplify this fraction, this division by 13 to get to this standard form first. Meanwhile, for this part, because it is a division, so we need to time with its conjugate. Then simplify this conjugate to the answer of 2 over 13 plus 3 over 13i. Then lastly, we do the operation, additional population for these two complex numbers to get to the 5 over 13 plus 12 over 13i.